All right, hello everyone. This is week 9 of backend development with Python and MySQL. This week we are going to look at Python data types. We're also going to look at how to cast from one data type to another, and then we're going to look at what the numeric data type looks like. My name is Mildred. So last week we looked at setting up our environment, and we also looked at the syntax of writing Python. We looked at variables, and we said that a variable is like a container for storing data values, and those values can be of different data types. Now we have numeric data types, which means that they are numbers. The types of numeric data type we have integers, which is written int in Python, and int just means any whole number, either positive or negative number. So let's say x is equal to 5. This is an integer. Let's say y is equal to -2. This is also an integer. So this is of int type. We have another numeric type we call float, and this is a number type, but that has decimal points. So let's say we have a is equal to 3.5. This is a floating point number and is of type float, written float like this in Python. And let's say we can have b is equal to minus, so it's either positive or negative, but with decimal points, it can be more than one decimal point. Okay, so this is int and float numeric data type. We also have something we call complex, and for those who are in physics, quantum physics, and learn all of those electrical engineering, complex data type will come in handy. But for us here, it will be of little or no use, but we're just going to look at what complex data type is like. Complex just has a real part and an imaginary part, where we have things like let's say c is equal to let's say c is equal to, let's say, 3j. So where we have the real part and j is like the imaginary part. So always use j to specify imaginary part. So I'll tell you where this is applicable, because it won't make sense here. Like if we have things like we're solving fluid dynamic problems, or in electric engineering we're doing this AC circuit analysis, where we want to have the real part to represent the resistance, and we'll have the imaginary part to represent the reactance. So that is where complex numbers come in when you are dealing with quantum physics or electrical engineering. But this is how it is represented in Python. We have a real part, and then we have an imaginary part. Okay, so we're going to look in details at them and how we use them. So these are the three numeric types that we have. We have int, we have float, and then we have complex. In Python, we have a function that we call type, and we use this type function to get what data type a particular variable holds. Let's say we want to print out. We'll say print type x. So we want to print type x, and when we save and run this, it will tell us it is of int data type. So we know that an integer is a whole number, either positive or negative. We'll do type y, it will also tell us it is of type int there. When we do type a, we will get the float type, and we'll do type b, we'll see it is of type float. When we do the type of c, then to tell us it is of type complex, because this is how we present complex, having a j as an imaginary part, and then we have the real part, which is the number. Sometimes we present it by writing things like x is equal to, let's say, 3 plus let's say 7j. So this is also a complex number written like this. So don't bother so much about complex numbers. We are not going to do anything deeply with complex number, as it is not going to be applicable in anything we're going to do. But you need to know that it exists, and when you have those kind of programming to do, you know what data type you are expecting. And then in our advanced course, we are also going to do things like when we have type hinting, or we do return types for production development. That is where all these data types really comes in handy, where you need to specify the return type of a function when you create a function. And those in course 3 that are in this class will recognize that in our week 6 we have delving deeper into functions, where we create functions in a production ready way. And so these are the numeric types that you need to know: int, float, and complex. And we can change them from one type to another in something we call casting. If we have a is equal to 3.5, this we know is of type float. Let's look at it again. And when I save this and I run, we'll see that it's of type float. But when I say z is equal to, and I know that a is float, but I want to cast it to an int, I use this int, and in the parentheses of the int here, I'm going to put the a, and by the time I say type of z, you will see it's no longer a float, but it's going to be an int now, because I have casted it to an int. So anytime we want to cast from one data type to another, we can cast between the 3 numeric types. We can also cast between string and the numeric types. And what we do is just to use all of these constructor functions, int, like this. So we want to cast to int, we use int, and in the parentheses we specify the value we want to cast. We want to cast to string, we use string str. We want to cast to float, we use float, float like this. And we want to cast to complex, we use complex constructor function like this. So you specify the value you are casting within the parentheses. Okay, so that's what we call casting, changing from one data type to another. So if you have a floating point number 3.5, you want to make sure it is an integer. It will either round up. So let's see what happens. Z is equal to int a, and let us print out not type of z, but let's print out z and see what the value is going to be now. Since we have casted, it's now 3. So it just drops out the point and makes it a whole number. So it doesn't round up or round down. It just gives you the whole part of it. So the same thing, if we want to cast this to an int b and we print out b, it's going to do exactly the same thing. We're going to have so we have 2.56. We're supposed to be casting, let's see this, z is equal to int b. B is a floating point number, and we're printing z, not b, sorry. And so when we print this, it's going to give us the whole number minus 2 here. Okay, sorry, hold on. Yeah, so we have looked at all of the different numeric data types that we have, and we know when to use them and what they stand for and how to convert from one data type to another. We have another data type we call the string. Like we have said, string sequence of characters in either single or double quotes. When we have things like first name is equal to John, this is a string. Anytime we write sequence of characters, a word, a sentence, a text, and it's called a string, we must put them within quotes, either single quotes or double quotes. Okay, and string forms one of the sequence types of data. So we have sequence data type that are made up of strings that we just looked at. Then we have lists. Now, list is also a variable we can declare. Let's say I want to have things like colors. And this can store several values instead of a single value. When you want to create a list that can take several values at once, you can declare them using a pair of square brackets, and within the square brackets, you write the list of items. The items inside can be different data types. We can have strings, we can have numbers, any numeric type. So let's say colors, we have red, let's say we have green, and then we have blue. So this is a list. So when you have anything within square brackets and they are separated by commas, and even if they're not separated by comma, you can have one item. But once you have a square bracket, we are dealing with a list. List is used to store several values in one variable, and this is a topic we're going to look at later on when we look at how to go through items of a list and the properties of a list. But you just need to know that this is a data type that we have that we use to do several things. It's a very powerful data type that you need to know in your software journey, because in all interviews you have to deal with lists a lot. We have another sequence type we call tuple, and tuple is just like list, just declared with a pair of parentheses like this. So we can do with a pair of round brackets like this. Just like lists, they take values like this. They have almost similar properties. We are going to deal with the difference in their properties. But one of the major reason or the major difference between lists and tuples is that tuple, we can use this to store data that we don't want to modify. And when we get into the software development part, where we are extracting data from the database, you don't want this modified. We're going to be extracting and storing them in tuples like this. And so this is going to be one of the use of tuples, but we're going to expand on this. But this is a data type. Tuple is declared just like list, but instead of the square brackets, we use a pair of round brackets, and then we list all of the items within the tuples. Okay. So that is the second sequence type that we have. The third sequence type that we have, so we have strings, we have list, and we have tuple. We have another data type we call Boolean. Boolean is just true or false, yes or no. It just takes one of two values. For instance, if I say x is equal to, or let's do like 10 is greater than 5. This is a Boolean. If we try to evaluate this, it will give us, is this true or is this false? So whatever we get, let's say x is equal to 10 is greater than 5. If we want to see the type of x, let's say print x, we'll print x first, and then let's print type x. When we run this, I'm going to clear. We're going to see that the x is going to be true, the type is bool. And the reason is when we do an evaluation of greater than, less than, equal to, want to compare values, we get the result as true or false. And when it is true or false, it is of Boolean data type. We have another data type we call dictionary. Dictionary just stores value in name value pairs or key value pairs. Just like we have list and the rest, this is going to be something that you have name for the value. All the values are named. So when you want to get the value, you call the name of the value. Let's say, for instance, I have a dictionary or a variable called person, and then I'll put the key here will be first name, and then the value of the first name will now be, let's say, John, and last name Doe, and then the age 30. And so this is how we write dictionary in Python. So dictionaries are name value pairs. We specify the name colon the value, the name colon the value. So the name is just like the key. So when we want to get the first name of a person, we just call the first name, it tells us John. We call the last name, it gives us the value stored in the last name, and then the age, and then the city. And so we're going to expand on what dictionaries are. We declare it in a pair of curly braces like this. We have the keys, which are always quoted, and then the value, which can be of any data type. Okay. We have something we call sets. Sets are like dictionaries, like list also, but declared like a dictionary with a pair of curly braces like this. For a set, you do not have name value pairs. We just have it like, let's say, Jane Doe, and let's say we have John, and then we have, that's the age 30. So this is the set. One of the use of set is when you want to have unique values. They don't allow duplicate values. And so when you have a list of items that are duplicates, so let's say you get a list of all your items from a database. This time you are not concerned about whether the items should be changeable or not, but you don't want any duplicate values. You want unique values. You can convert the list to a set, and set automatically drops out duplicates and puts only one unique value of every item that you have. So when we want unique values, we use sets. Dictionaries for name value pair. List just to have a list of all items. It doesn't, it's indexed and does not care if they are duplicates or not. And then we have tuples also if we want to deal with items that should not be changed. Okay, so these are the data types that we have. We have binary types. We're not going to look at that because it's not something we're going to really use in this course. But I want you to research those data types. These are the major ones that you will see and that we're going to be using as we go along this journey. Anybody with any question before we go further? Okay, in the absence of questions, we're going to look at Git and GitHub, and we're all going to look at how you create your repository and how you push and pull from the repository. I think this also makes up part of your assignment 4, just because we have extra time to go over that. For Git, you always have to come to github.com and create an account if you do not have an account. Okay, you sign up here. If you have an account already, do not create a new account for the course. Just use your old account. So I will use my account. And I'm logged into my GitHub. Now, once you get into your GitHub account, you have all your repositories. People who have GitHub for a long time and have done a lot of software projects, you're going to have a lot of repositories. But the first thing you want to do is to click on this, your icon here, and you want to go to your repositories to see the repositories, but you don't have one. So let's assume that the first thing you want to do is to do the settings. And these settings is where you set up your SSH keys. Now, for your SSH keys, you want to go through the links that are set to you in your assignment file to see how to generate SSH keys between your system and GitHub. And when you get that key, you want to copy the key, come here and add new SSH key. I'm not going to do that because it will expose the keys that I expose my key. So I'm not going to be pasting any of my keys here. So you're going to give it a title and paste your key here and add the SSH key just for your system to be able to communicate with GitHub. And once that is done and you do the test and it gives you the success message that you have successfully authenticated to GitHub, it is now time for you to start creating repositories. Now there are many ways you can start creating repositories. You can come back to your personal profile here and then go to repositories and then create new like this. So for repository, you always have the name of the owner, which is the name of your account, / the name of the repository. So when we say repository, it's just like a house, or it's just like you created a folder to store all of your codes for a project. And let's say we want to create a repository to say cost2, let's say cost2 repo as a name. So we have this repository called cost2 repo. The name is available, it tells you it's available. You can put a description here for the repository, what it will hold, what it's about. You can put that there. If not, if you don't want to do that, you want to select it, public or private. Private repositories are paid for. So all the repositories for the course will be public. So you leave as public. Do not select add readme file here, just so that you can push a particular folder from your system to this. So let's say cost2. I'm going to change the name. I'm going to say 02-24 and I'm going to create repository. Now this is going to create an empty repository for me to initialize a repository from my system and push here. We have another method where you will initialize with a readme and then you will clone the system, clone this repo to your system. We can do either way, but I'm going to show you this method, which is more difficult, and the method of cloning, we'll see if we'll do that later, or you just go to your pre-recorded video and see that. So I have this WebDev02-24A and I say, let me create repository. So I have a repository here. There's nothing in it. I have to push something into this WebDev02-24A. What I will do next is to now come here, go to my desktop, and I want to create a folder here, and I will name this folder WebDev02-24A. Okay, this name is already available. Let's see where the name is. WebDev02-24A is here. I'm going to change this one just so that I can use that name. Then I will name this new folder WebDev02-24A. Now I have this folder called WebDev02-24A. When I come to my Visual Studio Code, I want to come to File, I want to add folder to Workspace, and I'm going to be getting the WebDev02-24A and add. There is nothing in this folder. We can create anything we want in it. If not, we leave it. Now, here my terminal is on the COS224A folder, is not on this WebDev02-24A. I want this to be the folder I have selected here. So I'll cd out to my desktop, and then I'll cd WebDev02-24A. So cd means change directory. When you use 2 dots and a /, it means go out of the current directory. And when I go out, I'm now in my desktop, and I know that my WebDev02-24A is on my desktop. So I'm just going to use change directory to the WebDev02-24A. Once I'm in this directory, the first thing I want to do is to initialize this directory as a repository. So I'll do git init like this. And once it's initialized, I'll see initialize empty git repository. And I have this now as an empty repository. Now I will come back to what I have done here and look at the instructions. I want to create a README file so that I can push this to that repository. So I'm going to echo this. I'll just copy the codes back there that they have there, which is easier for you to do. I've initialized already, so I'm just going to add this. So I'm not going to copy the code there. I'll just say git add. You can use dots to add everything that you have. You do git commit and put your commit message. So when you write git commit, the M flag just means commit message, and I'll put first commit. And then you want to see the branch you are on. This, you want to create a new branch, which is the main branch, because if you don't have the same branch on your local repository, which is on your system, with the branch that is on GitHub, you will not be able to push to that branch. So let's say we want to create a new branch. When you want to create a new branch in Git, you do git branch, capital letter M, and then you create the name of a branch, main. You can also use git switch like this, git switch main, which means that you are creating a new branch, main, and you're switching over to that new branch. So you can use either one, git branch dash the M flag and main, just like they specified here, or you want to use git switch main. So either one you use will do the same thing. I'm just showing you there are 2 ways to do it. I can do that, and I've reset branch main already because I'm using something different. And once you do that, the next thing to do is to add this to the origin, and then you push to origin main. So I'll do git remote add origin, and then we'll say git push origin main. And then if you have a pass key, when you generated your SSH keys, it will ask you for the pass key. You'll see a new branch created main, and it has pushed to GitHub. When I come here and I refresh this page, we'll see that this is no longer there. We have our README file pushed here, and all it has there is the WebDev02-24A that I pushed to it. So this is how you communicate from your system to GitHub. We're going to use that later when we start developing our softwares, and when you start having to push your assignments to GitHub for submission and grading. We also have the other way we can do this by creating a full repository and cloning the repository to our system. And the way we can do this is, I'll just show you. You will come to, let's just go to any other repository without having to create a new one. Let's say I look at all these repositories and I decide I want to clone a repository, this repository. What you will do is to come to this code here, select, make sure this is on SSH. You can also use HTTPS, but I'm using SSH. If this is on SSH, copy this, come back to your terminal here. Make sure you navigate to the directory where you want to clone this. Let's say I want this to be in my documents, and I'm in my, let me say this, and CD, the document, and I want to clone this in my documents folder. What I'll do is to type git clone, and then I'll paste what I copied, and then it's going to copy that whole folder into my document. It will also always ask me for my pass key if I set one during it. And when I come to my folder here and I go to documents, I should see the edu folder I just cloned, which is here from the system. So if I do list, it will show me all of them, and I have that folder here on the system. So this is just a basic walkthrough of it. If you watch the video, you will get a deeper understanding of Git and GitHub, and it will help you in your assignment for you to be able to complete it. Do you have any question? Okay, in the absence of questions, don't forget to book a one-on-one session if you have difficulties. Always book on time, not close to assignment deadlines, and you can post in the WhatsApp group if you have questions that you want to be answered immediately without a one-on-one. Contact any of the admins on WhatsApp, and we'll see you next week.
Thank you.
All right. Thank you.
Thank you.
All right. Thank you very much.